Hello, philosophers. This is Logic 1.4.2 Practice Answers. Please go to please go and actually try out the stuff first, by the way. Don't go to this first. See if you can make sense of it first, and then only after you can't make sense of it, come and check your answers. Or even, yeah, just come and check your answers after you've done them. All right, so one more time, let me refresh your memory on what it is that we're doing when we're doing these kinds of logic. We're saying if you have arguments of this form, if people are arguing this way, they're saying this is true and this is true, and they're saying based on these two things, this conclusion is true. We want to see, is that the case? Is it always the case that this conclusion has to follow from these kinds of premises? So this one says P or R, that's the first premise, and this premise says not P. Right? Is it always have to be the case if you have these two premises, then the conclusion is true? So here's an example. If I said cookies are made with sugar or they're made with chocolate, right? And let's say the cookies are not made with sugar. Excuse me. Does it have to be the case that the cookies are then made with chocolate? Well, you could probably see from that example. Then, yeah, I mean, this is saying that at least one of those two things are true, right? Either they're made of sugar or they're made of chocolate. This is saying that one of those two things that we said had to be true, at least one of them is false, so then the other one's gotta be true, right? Maybe that's a bad example because a lot of cookies are made with sugar and chocolate, but you get my meaning, right? So what we'll do then, in order to see that this conclusion has to follow, we start off with an initial list where we have both premises written down and the negation of the conclusion. We want to see, is there any way where the negation of the conclusion, in other words, not the conclusion, is there any way for that to make sense? If there's ever a way of assigning these truth values where the conclusion can be false while the premises are true, and you don't contradict yourself anywhere in there, then we'll know that we haven't proved anything. So the only thing that I can do with this, the only rule to apply is the OR rule. So I'll apply it to the P or R, and I'll get P on one side, R on the other side. Now, I have two different options here, right? Two different branches. So what I need to do is I need to go start at the bottom and go all the way up to the top and check, is there any contradiction in this branch? I have a P here and I have a not P here. That means that this branch doesn't make any sense. So when I assumed that R was false, I got a contradiction out of one side of it. Over here, I go up R, not R. Oh, I have another contradiction. So both cases, in either case, when I assume that R is false, I contradict myself. So I show by that this argument has to be valid. All right, let's try 2. All right, true is P and Q are not P and R, or P and R, excuse me. So I contradict the conclusion, right? I negate the conclusion. I say not P and R. And let's see here. I'm going to use first the AND rule. Remember, I said that the easiest way to do this is to apply the rules first that are nice and straight. Don't apply the rules that break things up just because it's easier that way. But it doesn't really matter. Either way, you would get the correct answer. So, not P and R. I'm sorry, P and Q. I apply the P and Q rule and I get P, Q. Then there's the not and rule, right? This one right here, not and. And it splits off into two nots, right? So this is going to split off into not P and not R. So that's what I got right here. Not P contradicts P, so this branch has got a contradiction in it. Not R contradicts R, so this branch has a contradiction in it. Both branches close. This is a valid argument. 3. P or Q not and R entails not P. Let's see if that works. Well, first I make my initial list, negating the conclusion, right? The easiest rule to apply is the not rule, right? It's like the double negative. So not P turns into P. P or Q and R, and then I have to apply the AND rule, right? You have to apply remember, the outside rules first. You can't apply the inside the parentheses first. If you apply those first, then you've got this guy sitting out here. You have no idea what's going on with that guy. So you have to apply the outside rule first. So I apply the AND rule, and I get P or Q here, R here. Now I'm left with a P or Q, right? Which is this rule right here. They're going to split P, Q. I start up here, P, no contradiction there. R, no contradiction there. So this is an open branch. Now, I could stop right here. I don't really have to evaluate the other side, but I'll do it just for fun. But as long as one of them, at least one of them is open, then this is an invalid argument. Because remember, you're just saying, is there any way for the conclusion to be false and this thing makes sense? Well, same thing over here though. I look Q, no contradiction, R, no contradiction, P, no contradiction. So these are two open branches. And once you've got that down, you have to see what is the counter model. Remember, a counter model is just to say, when I got this right here, how can I make the premises true and the conclusion false? What do I have to assign? What truth values do I have to assign? And here's my counter model. I can just read off of this branch, right? When P is true and R is true, then the premises will be true and the conclusion will be false. Notice I don't have Q on this branch right here. What that means is I don't really care what Q is. As long as P is true and R is true, whatever Q is doesn't matter. The premises will be true and the conclusion will be false. Right? So let's see. Here's the counter model. P is true and R is true. And we can plug those back in and see if that makes sense. First, I have this AND statement, right? And the AND statement says both of these two things have to be true. P or Q has to be true and R has to be true. Well, down here I said R was true, so I know that this side is true. But what about the P or Q side? Well, the P or Q means at least one of these two things is true. And down here I said the P was true, so it is true that at least one of these two things are true. And you can also kind of see, since Q is the only thing here, you can also kind of see if Q isn't in this branch, what that means is I don't really care. Why? Because look, P is making this whole thing true. I don't really need to worry about if Q is true or false. Q could be true in this case, it could be false in this case, it doesn't really matter. Either way, P has made this whole thing true. Alright, so this premise is true. R is true, I said over here, so this premise is true. P is true, I said, which means that not P is false. So this conclusion is false, although the premises are true. So this is an invalid argument. Alright, P or Q or R, does that entail R, P, or Q? Alright, well, we'll start at our initial list. Notice negating the whole. Here's a really important thing. You want to make sure when you're negating big things, you're putting parentheses around those. If I hadn't put those parentheses, then this would be not R or P, or also Q, right? So either not R or P is true, or Q is true. No, I want to say neither one of these two things are true. It's not the case that either R or P is true, or Q is true. So you make sure you get those parentheses around that guy. And I will apply the not or rule first. The not or rule to this. And notice I'm applying it to the, the or, this or right here. I'm not applying to the inside guy, right? So that gives me not or P, R or P, and not Q. And then I'll apply the not or rule again to not R or P. And I'll get not R, not P. And then I have only the ors left, and here's the or rule right here. So that's going to split into P or Q, R, right, like that. And again, notice this also confuses a lot of people. You see these arrows and you say, wait, but how did you get that out of not P? No, I didn't get it out of not P. I got that out of this. And I just write these arrows right here just because that tells me that out of all this jumble, I'm getting these two things, these two separate branches. That doesn't mean you're getting them out of this specific one. So I got P or Q or R, P or Q, R. And then P or Q, I have to apply the OR rule, right? So I get PQ, P on one side, Q on one side. R contradicts this not R, so that cancels out. That contradicts right there. P, I go up and it contradicts not P. Q goes up here and it contradicts not Q. So those both close out. So this is a valid argument. I know a lot of you guys, especially when you've seen a lot of this, when it gets complicated, you see, XXX and you say, this must be all wrong, right? No. Remember, we said the negation of this conclusion, right? So we want these to all be wrong. We want it, if this is proved, if you do the opposite, right? And it doesn't work. So, last one, if P then Q or R, so at least one of these two things are true, either if P then Q is true or R is true. Not the case that not Q or R, so if not Q or R means at least one of these two things are true, not Q is true or R is true, then not that means it's not the case that at least one of these two things are true. So they're both going to be false. And then does that entail not P? Well, let's see. We'll make our initial list. I negated the conclusion here. Not P is the easiest rule, right? Just turns into P. So not P, P. Then I have a not or rule. I'll apply that first right here, right? So I get not Q, not R. The not rule is really easy, so that turns into Q right there. Now I have the this either or rule. If P then Q or R, so that's this rule right here. I get if P then Q on one side, R on the other side. Now I have, I have a contradiction right here, right, by the way, R and not R, so that's a contradiction. And I have to apply the if P then Q rule, so not P on one side, Q on the other side. So I look up here, not P, I have a contradiction there. Q, I don't have a contradiction for. Not R, I don't have a contradiction for. P, I don't have a contradiction for. So although this branch closes, this branch is open, that makes this an invalid argument. There is some way, if I say not P, if I have these premises true and this conclusion false, there is some way where that makes sense, where I don't contradict myself. So let's find the counter model. Well, the counter model, in this counter model, Q is going to be true, R is going to be false, and P is going to be true. So here's my counter model. Truth value of P is 1, truth value of Q is 1, truth value of R is 0. And again, we can plug these in to make sure that they make sense. Well, this whole thing is true if at least one of these two things are true. That's what an either or statement is. If P then Q is true or R is true. Here we said R is false, so that means this has got to be true over here for this whole thing to be true. Now an if-then statement is true if the conclusion is true, right? What you're saying is if you have P, then you're going to have Q. Well, if you always have Q, then yeah, whether you have P or not, then this thing is true. So here I see Q is true, so this whole thing is true, right? So at least one of these guys is true, so the whole thing is true. This, remember I said, a not or means that none of these two things are true. The or statement means at least one is true. The not or means no, it's not the case that at least one is true, so both of them are false. So first I see R is false already here, right? Now I want to see is not Q false, right? Not Q has to be false. Well, Q is true, so not Q is false. So R is false, not Q is false. That means both of these two things are false. So not the case that this is true. It is true that neither one of these two things are true. So this is true, this premise 1, premise 2 is true, not P. Now let's look at that. I have P as true here, that means not P must be false. So yeah, I have the conclusion false and these two premises true. So there's your counter model, and there's your answer.